Hi, welcome back to the channel. If you watched some of the live streams, you'll notice over the back week or so ago, late February, I did a quick analysis of an enormous Ferranti amplifier used in a Compton theatre organ, the Melotone amplifier. It's a big old beast in the sort of mid-30s, weighs an absolute ton. I've got it on the bench beside me, so I keep looking at it. It's a proper a boat anchor, as they used to call them in the States. It really does weigh, I should think, around about 100 weight, if not a bit more. It takes some lifting, mainly because of all the massive transformers. But so this is a sort of high power amplifier from the 30s that we use on these Compton theatre organs. This can deliver using the two DA30 output valves, which are like a pumped up special version of the PX25. This can deliver 45 watts of undistorted power, and originally went into like a massive 8-foot horn loudspeaker that would have been used in the cinema, because it was cinema organ, so this would have been, I'm assuming, in a cinema originally. But yeah, so I've done the analysis. If you want to go look at the analysis, it's on the channel. But what I'm going to do today, we're going to start recapping it, get a bit of cleanup. I'm not going to go massively, it's not going to be a really long video, because obviously it's going to be a lot of just changing condensers. But I'll bring you in and out as we start to restore stuff. What I'll do is I'll just spin the camera around so you can have a quick look at what we've got here. So as you can see, it's quite an imposing beast. It's a big old girl. I mean, the valves live behind here. They've obviously been taken out for now. They're all wrapped up nice and safe. The DA30s that live up here, the big output valves, obviously they draw quite a bit of juice and get quite a bit of heat. So they've got these guards around it to stop them doing that. But I've packed them all away because they're quite an expensive valve, and we don't want to have to go into replacing those. But it's just massive. We've got some meters at the top that I touched on when we did the analysis. And these are just done for setting up the biasing, etc., for the output stages. Like I say, there's various controls. Luckily, this one's got, that one's supposed to say, let me just focus on that. Sort of preset volume, monitor levels, and this sort of stuff. But so I'll spin the actual amplifier around. We can have a quick look at the back, and then we're going to start on with the clearing up and recapping. So I've just got it rested on a couple of blocks of wood at the minute, so we can see the back. It doesn't stand up on its own. It's too heavy for that. This is designed to go into a cabinet. I'll just take it down. Now we've got loads of capacitors replaced. Now these are massive 8 microfarad or 10 mics, I can't remember. Smoothing condensers, and there's loads more decoupling and extra smoothing, that sort of stuff. So these are all going to go. Some of these resistors, we last time, because we've done a couple of these in the past, a lot of these were off spec, so we'll replace those as well. Now the customer's not worried about this being like a like-for-like restoration. You're never going to see the back of this. It's going to get back in its cabinet. We're going to take all the old components that we do take out and give them back to the customer, because I think he wants to display those. So all these old condensers and resistors and things that will come out will be replaced. And we have got a lot of screen cabling to look after. And the customer's requested they have about sort of 6 feet extra, so these can get reconnected back into the console. There's some funny mains leads attached in various places, and I say the mains does go through, for those who didn't look at the analysis video, that goes through these mercury switches here. Now the last amp I didn't have those. This one has. I don't quite know what it's for. I don't know where the mains does look like it goes through it, but who knows? Till I have a good look at it, I won't know what it's for. I'm assuming twofold. They've used mercury for either one for the carrot, sort of. Hopefully, it'll start again. It'll be for the current carrying capabilities, maybe, but I don't know if these are even connected. And one of them is, and also because obviously the mercury inside the glass, you don't get any sort of arcing or flashing across, because obviously there's no oxygen in there, so there's nothing to sort of, so you won't get any sparks if it is switching a reasonable current, which this thing does draw. It's an enormous mains transformer here. It's huge, so I can just about get my hand across it. But these, well, obviously these are all going to stay in place. So really, it's just going to be a matter of changing out all these ancient capacitors. These aren't oil filled. These are like pitch and wax and everything else, lovely and nasty from mid-30s. So they'll all come out. Fit some tag strips into here for these new capacitors to fit into. We're replacing them a modern film capacitor, so they're less than a quarter of the size, so they'll get replaced. There's a couple of chokes up here. Someone at some point has fitted a fuse between here. That's broken and long gone. So we're looking at doing that, what they've done in the past. The original, let's say, the other ones I've done didn't have this. So I'm assuming that's just been added. Or maybe, Ferranti did it just to protect the HT side and protect the transformers. So yeah, it's I'll probably do a bit of time lapse on this one, and I'll sort of say bring you back in if anything exciting happens, but I'll just keep recapping it and sorting out all this cable and sort of bring you in and out as and when anything exciting happens. We can see a bit more now we've taken that mercury switch relay type thing out of the way, which the mains does go through. So there's obviously some sort of remote switching for the mains. You can now clearly see these massive big smoothing capacitors that they use here, and all this lovely old Sisterflex type, you know, woven insulation covered in varnish, so it's really hard. But this, let's say, we're going to have a good dig through here. Most of it's going to get replaced because the rubber underneath is all starting to break up and go. So we'll replace that with modern wires. Some of it might go back inside the Sisterflex if it's okay, just because it makes it nice and neat and tidy. But as obviously these are going to be in a different position. They're going to be a lot smaller and hidden right down in there. A few resistors that I say here that we'll check and go through. I don't know if that's original. I don't remember that bodging being on the other ones we've done. But we'll look into that. But I say, yeah, I'll put it back on time lapse, and I'm just going to start diving into these. As you can see, probably about 15 or 16 capacitors that are going to get replaced. While we're doing that, I say we'll just double check these resistors. But it's probably going to be as easy to replace those with new ones, just because the customer wants this to be as reliable as possible. So in some cases, it's best not to rely on, you know, 80-year-old technology, 80-year-old stock. We'll replace this with modern stuff, and I say the customer can have all this back for his display. As you can see, we've got the film capacitors fitted on a bit of tag strip here. Obviously replaces those big old brown blocks that were there before. As you can see, a lot smaller, and we can make it a lot neater. I mean, the original resistors were like half or 1 watt resistors. They have been replaced with modern ones, so we can make it a lot neater in there. So there's a few that haven't been soldered in yet because obviously I've got wires to take off to elsewhere. HT comes in on here, so we've got to do that when we get up and sort all these main smoother capacitors out up there. So what I'm going to turn my attention to next will be this block down the bottom here. You can see with all those resistors strapped across the top, and then we'll get on with the HT. So I'm still to finish off over here because I've got some other wires to disappear off down to the front of the amplifier where the controls are. But you can see I've just replaced the main smoothing capacitors with these German blocks I like to use for the non-polarized style. But just as a size comparison, there's the originals, two 10 microfarads at 700 VDC, and these ones are 10 microfarads at 900 volts. So yeah, it just goes to show the tiny little things compared with these massive originals from, say, the mid-30s. I've got to concentrate on just connecting up the HT. There's a fuse in here that's smashed, or a fuse holder, so I'm going to replace that, sort the wiring out on here, get some HT back down to here that we can then feed that off to the capacitors over that side. Just sort of tidy some of the wiring up down this side. You can see, because I've moved a couple of these capacitors that were down the side here, moved onto this little tag strip here, so I've just had to sort of rejig the wiring a bit. You also notice that I've got an earth bar running down all the way. None of these condensers are earthed to the actual chassis, they're all earthed to the central point at the front, like a star earth point, so they all get earthed at the same position, they're not earthed to the actual chassis. But yeah, so let's just get these massive old beasties. As you can see there, look, you can quite see it, 10 microfarads, 700 volts DC, or 750 volts working. Oh, and they weigh a ton. So now we've taken those out, I've got a lot more room in here. So I'm just going to make these the wires from the HT nice and neat. We're going to put a few little, either clips or pylons to take this wire down. That's what I'm going to do now, and we're starting to get there. I've still got to concentrate on those capacitors down at the front. They still need doing, and they'll sort of, once we start taking the HT from up here and travelling it down to here, we'll be able to get that sorted out. Also, I don't know if I mentioned it yesterday, we've got this massive, just focus on it here. This chap is a big selenium type H rectifier they use for the bias for the output valves. I have got a hand-drawn schematic for this part of the amp. This end of the amp has changed slightly. This isn't the same. But this end, as you can see, you've got just a diode in here, which gives the negative voltage for the bias for those volts. So that'll go, and we'll replace that with a modern silicon jobby. Because that's bound to be kaput, and we don't want to leave any old silicon stuff in there. Sorry, selenium stuff in there. But yeah, so I'm just gonna. This has changed. I've noted some other changes to the drawings here. This is for the Mellotone amplifier, but it's for a different organ. So it's similar, but it's not quite the same. But it gives you some pointers as to things where they should be and what we're looking at voltage-wise. So yeah, I'm going to crack on. I say get this HT sorted here, then we can concentrate on those capacitors and diode at the front. So all the wiring for the HT has been taken care of, all down at the condensers down here. And you can see there's a new fuse holder fitted up here where the original one was. A nice phosphor bronze. It's a really good quality fuse holder up there, so we're going to use that for protecting the transformers in case of any problems with the HT. Alright, so as I said before, I'm now going to crack on with those bits and bobs down the front, and hopefully we'll be able to get some power on it fairly soon. So you can see we've got all the capacitors, quite a lot of the resistors have been replaced. I think nearly all the resistors have actually been replaced. You can see down here, this is the bias section. We've got the diode in here, which replaced that great big selenium rectifier, with the smoothing circuit for that. That gives the minus 150 volts there or thereabouts for the output bottles. Here's the section for the preamps and all that, all in here with smoothing and decoupling. There's another little one hidden in there, and that's the one we saw earlier on with the HT up here. All the new wiring fitted, and it's all loomed up and laced up down the side. Still got these, a couple of loose ones that with these numbers on that go to other parts of the circuit when it's back in the cabinet, and that's the actual input to the first valve. There's a couple of sort of like earth leads here that connect to something. These are all numbered up, and I've taken a couple off, 5 here and 3 here, that were these little pieces of old cable. Now they're going to go off into the cabinet that this lives in. They want about 6 foot of that connected. Now, bearing in mind, I can't use normal sort of audio cable because this is going to be around about sort of 300 or 400 volts, possibly a bit more on here. So I can't use bulk standard audio cable because some of the stuff I've been looking at has only been rated for like 80 volts and 100 volts. So we'd have to do something for that, but that's not for this video. What we're going to do now is turn it over and sort of slowly bring some power up. You can see just that the mains is coming in here on this flexible, because you can obviously set the voltage tappings up here. I mean, chances are it's going to live the rest of its life at 240. But who knows? So that's on a variable still, so you can move that across. I've just got to take the neutral. That obviously plugs into that funny mercury switch type thing we've got with the relay coil. But we'll do that later. We can fire it up without that. I'll take the neutral to the common mark on here, so we can liven this up, get some valves in, and we can start actually doing some testing to see if we've got any problems with the pots and that sort of thing. But next time you'll see it with all the valves in. So I've turned it all around. It's sitting on the bench, as I say, on a couple of blocks of wood because it's really quite heavy. What I'm going to do to start with is just put the rectifier valves in. We've got these bottles here, so we'll get those in on the front of the set. Lean over to those. These are just paralleled up for the current capability, so you've got 2 rectifiers for this beastie. He says, look for the way the pins go in. Okay, so the rectifiers are in. I'm just going to put a temporary mains lead on. This is a bit of a dodgy connection, but it'll be fine for now. It's going through the limited supply as well. So let me just hook that up temporarily for now. power off, limiters on. That's all out of the way. Okay, so we're going to do so. I'll just stop my stuff. I will apply some power. I'll keep an eye on the voltmeter. You can probably just about see it there. Just initially to see if the HT is going to come up. Obviously, it's probably going to go quite high because there's no other load on here. All I've got in at the minute is the rectifiers. So through the lamp limiter, just in case anything was to go short. Let's see what happens. Not a lot. Oh, there he goes, coming up. We'll be able to see how I'm running currently at 150 volts going into the actual set. Wow, look, the HT skyrocketing right up to 625 volts. 635. I'm not going to bring much more than that. It's just to sort of show there's any fault on the HT, and that's sitting there quite nicely. And you can see the brand new condensers, it's dropping down really slowly, so it's ramped up to 600 volts. Because I say, it's not on load, so I was expecting it to shoot up. Next job is I will start putting the output valves in and some preamp valves and just see what else we get. But the HT's coming up. So we'll put the DA30s in, these big beasties. They're all filthy, they'll all get cleaned up. But these have come out of, I'm assuming it was working when it came out, or these are the valves that come with it. So if we need to get more valves, we'll have to look into it, but we'll get these ones in. There's one. And here's the other one, slightly less grubby. That one's going to go in there too. So that's the output valves in now. Now and again, you can still see those condensers are brand new condensers. It's still dropping out at 250 volts. Obviously going to draw a load more current now these valves are in. There'll be sort of several amps for the heaters on those. So let's just see what happens when we bring it up now. Right, so we're coming at 80 volts, 90 volts. Still going for a limiter at the minute just to keep an eye on what's going on. Obviously the HT is dropping down dramatically now because the output valves are now starting to draw current. I can just hear a very faint noise from the transformer. Sorry, from the loudspeaker, because I've got it hooked up on one of the bench speakers. Right, so the HT is sitting at 280. I say these run around about 500 volts. What I do need to check is that we've got the negative bias going to those valves as well. Obviously, there's still a very limited supply. Take that off there carefully. So bearing in mind, we're now, several hundred volts flying around in here. Just carefully get in there and connect to that point. What have we got there? Yeah, so we've got a minus 112 volts for the bias, which is right because I say the juice is down low at the minute. Nothing's drawing excessive amounts of current. It seems to be okay. I think what we need to do now is just get some preamp valves in and just sort of slowly start seeing where we go from there. Can't see anything here, anything. I mean, it's the way it was built before. It was so, with all these solid conductors and that sort of stuff, it makes it quite easy to see where the wires are going. So, I mean, we have sort of shotgun the whole thing on the way through, but we've got the data. And even though there's lots of components, it's not a particularly complicated amplifier. It just looks like there is. But yeah, so that all seems to be quite happy there at the minute. Let's see what HT we've got up here. The HT here obviously feeds out to the other various stages. Let's just click onto here. That's fine. That's HT going to the transformer. Make sure we've got okay winders on the transformer. 148 on there, so hopefully we've got the same on there. That's good. So we know the output transformer primary is good. This is a choke here, so I'm assuming that's still going to be working to the side there. I can hear it fizzling on the speaker. Yeah, the bulb up the top there, the lamp limiter supply, is shaking around a bit. I've had it before. The rectifiers can cause problems occasionally. It's also got those meters on the front, so I can see what current, if any, are being drawn. So yeah, they're drawing a little bit at the minute. I can see what they're doing. Output valves there. The problem with the meters, the glasses have dropped back, so they're not going to be a lot of copper at the minute. We can sort of go through that as we go. Right, what I'm going to do, I'll pause it, I'll get the preamp valves in, bring it all up to where it should be, nice and slowly, and see if we've got any faults, and hopefully we'll get some sound from it. Right, so I've got the valves in, we'll bring it back up again on the supply. I'll connect up to the HT still, so we've got all the preamp valves in, everything's in the output bottles, so I'll monitor up here what's going on, bring that on. Yeah, but we've got to need one more because there's so much current being drawn. It's got to draw quite a bit of juice. So I'll just monitor these on here. So we're currently set 160 volts on the Variac, going up, so as you can see. Whizzing up 230, 250, 350, sorry, you might be able to see that on the back there. Right. What are we doing? So if I touch. There is a volume control up here as well, preset volume control. Now we're flying down. 190, 180, what's happening there? Let's just have a look at that. There's a fuse there, it's not drawing too much current because that'll pop. What we do it on here? Alright, get in there. Can't see that, I've got my other set of glasses on. So this is just looking at that negative voltage coming for the bias. Whoa, 340. And we're only 152 volts. Right, well something's not right there. That's its own separate little circuit, that bit. As you can see on here. We're looking at that section here now. So I've got the meter connected here, which is straight after the rectifier. And I should only be getting sort of 150 volts or something, and we're getting, what we're now, 341, so something's going wrong there. Now that suggests to me that maybe we've got a neg loose somewhere. Let's just turn it off and have a, oh, no, prat. Helps me put the fuses back in, what a pilchard. Right, let's turn that off and put the fuses back in. Because the fuse on this, what an idiot. You can see on this drawing, the fuse is in the negative. So that's why it's reading that steady voltage. I said wrong with the neg, the fuse is missing. So fingers crossed now, when we put it back on. Through the limited supply. Right, that's looking better now, 124, 125 volts. Let it all start to warm up. 190, 170, right. The valves, the output valves now starting to draw some current. I've forgotten to take that fuse holder out. Hey ho. Right, let's have a look at some of the voltages around here. This should be sort of, yeah, 240. Because that's through, right. So we can bring the final stage in. So what we're doing now, we're now drawing 90 watts, so nearly half an amp. Oh, that's, you might be able to hear that. Obviously, I'll have to speak over the hum. Obviously the first valve is top cap, and that's not connected to anything, and that goes off to something in the organ. So if I get my hand, I'm not touching it, I'll blow the speaker in the next week if I touched it. Wow. Tons of gain, kiddos. So let's just check the HT up on here on the top row where it's coming off, which is actually there. 421, so we're a little bit low on the juice. We're sitting at 223. Can we adjust that with this and do the hum? Hey, that's better. Right, let's turn that down. There's a little preset control up here. Also, I'm not going to run it at full tilt for long. They've got the presets up here I need to adjust to set the bias right for the valves. They want to be, I think it does tell you in the front, so 20, 30 milliamps or something, I think. 50 milliamps on the outputs. Yeah, so we can set those, but let's say the glasses on the front of the meters have dropped back, so they're hitting on the needle. So those meters can't work. So I don't want to run it too long in case those poor output bottles are sitting there and a bit heavily negative, and we don't want things to go wrong or draw too much current if they're not negative enough. So I'm going to spin it round and have a look at those meters. But apart from that, at the minute it's looking good. So fingers crossed. We should get some sound for it soon. Got this chunky resistor in here, which was originally a sort of massive clump of other resistors that have all been sort of bodged in over the years. Whether that was to where one had gone or whether they were just trying to get the HT up a little bit, who knows. But I want to just double check. I'll put a 5 watt resistor in here at the minute. I'm just going to quickly do, I've just taken the volt read and we're getting approximately, so we've got approximately 230 volts across that resistor. And the resistor is 12k, so that's 12,000 ohms. So a quick bit of Ohm's law, which is VIR. Always try it like that. So we've got the volts, which is 230. We've got the resistance, which is 12,000, sorry. So if we can see from here, volts over that gives us the current. So if we do, I'm going to use my rather ancient calculator that was left to me by my great auntie years ago, and it's still going. Original battery, as far as I'm aware. 230, so it's volts divided by the resistance, which is 12,000, equals 0.019. So we'll put it 0.02. Close enough. So it equals 0.02 amps. Now we want to work out the wattage, obviously, from that. So that's I always remember these little calculations like this one I done at college. So you get the watts, amps times volts. So we've got the watts is going to equal amps times the volts. So we've got the which we typed that in there. So the amps, which is 0.02, you can just make it on there, 0.02 times the 230 volts, 4.6. So it's 4.6 watts. So it's 4.6 watts. Now, as you see, that is a 5 watt resistor. And then again, it's a 5 watt Chinese resistor. So who really knows? What I'll do then, it's going to be a little bit close to the knuckle, that one. So what I'll do, I'll replace that with something a little bit more chunky because we just want it to keep going. We don't want it to burn out. Not that the heat's a problem, it's just we don't want it to burn out. So I will swap that one out. But for now it's fine for testing. But before it goes back to customer, I must replace that resistor. Let's turn it around and hopefully we'll be able to get some audio from it. I nearly forgot, before I go too much further, I do want to just check these meters out. As you can see, the glasses have dropped right back on there. So what I'm going to do is take these glasses off. This one's fine, it's just these two. The glasses have dropped back and then they are now pushing on the needle, so the needle can't move. So I'll whip these covers off, replace those. There's normally tiny little screws, but I can't... hang on, there's tape around here. Okay, so that one's been taped up. It's probably been broken at some point. So I'll just pause and we'll take the front off and have a look. So I've got those glasses off, or the front covers. This one's obviously cracked at some point because someone's done a very nice job of sort of binding it up with wire. You can see there's a crack inside there. There's these little aluminium rings that sit inside here. I was just trying to focus on my fingers. But what I'll do is I'll slide those rings out and get the glass so you can see it's loose. I'll take it out, give it a wash because it's blooming filthy anyway, so you can't see it. They're the meters. You know, all naked, nothing on them. I don't want to leave them like that for very long. This one's a little bit sticky, which we need to set. But I'm not overly worried. This is the one you really need to make sure that you can set up for the output valve. So this is the one I really concentrate on. This one we can sort of get around it. I think it'll still read. You might just give it a tap to get it to drop down. I've not got any meters that look like that, so we haven't got any we can replace it with. But anyway, so I'm going to go ahead and get these all glued back together and cleaned up. And then we can get them back onto the glasses. Sorry, the glasses? The meters. Alright, so the glasses are back on the dials. You can see they are actually reading something now. I've got the power on. You can set up the bias for these output valves. So say that's what this is for, really. To make sure it's all where it needs to be. You can click between the two valves. And then obviously these are then variable. And I've noticed, you can see the current changes as you order the bias on the pot on the valve itself. Now one of these valves is a little lower than the other. I'll mention that to the customer, but I say because you can set them on here, he can get some. And see, I can't get that any more than about 45 milliamps, and it says they're set to about 50. But yeah, looking at the data, what you need to look at is it's up to the customer to set these. But these are both. You can see on this one, there's a lot more available. So that's the this output valve is a lot stronger than this one, so they're not a very good pair at the minute, so they'll have to look and invest in a set of those. This rectifier, I've noticed, is, you can see it's really early. It's an Osram from the maybe early 40s, late 30s. This is a little bit later, war issue stuff. Everything else seems to check out okay, but I need just to put that that rectifier is a bit dicky, and tap it and it doesn't work very well. So that's not that I'm going to cover on this video. I've just got it jerry rigged up for the minute. I just got that tapped on the top there, so you can hear something come through it. But I can give you a little bit of the Seaberg 1000. Now, obviously, it's only, say, straight on the top cap of the first valve. There is shed loads again. I mean shed loads. I have no idea what the input to this is. It comes from the console somewhere. It's probably some ridiculously high impedance thing. So I've not matched it particularly well by popping it in that way. But it works fine. Sounds great. So I'm going to call this one a day on this video. I hope you enjoyed seeing it. It's nice to see some nice big DA30s working. These are rarer than hen's teeth. You don't see this very often at all. So it's really nice to get those going. All I'm going to do is just give these a quick wipe down, and then we can get that back to the customer. So I hope you enjoyed this video. Something completely different again. I try and do things that other people don't cover. I know we do TVs and radios as well, but it's quite nice to occasionally do something a little bit different. But I'll leave you with a little bit more Seaberg 1000. If you enjoyed it, say give us a thumbs up, hit that like and subscribe button, and we'll catch you on the next one.